Hello everyone, this is Mr. Appel, and today we're going to learn how to count. Okay, not just learning how to count, but learning how to count in a clever way using something called the fundamental counting principle. It's going to be our introduction to probability and statistics. Today we're just going to focus on the fundamental counting principle and how we can use it. Some common knowledge, some things that I always assume that people know, but every once in a while I find people that don't for one reason or another. When we roll dice, you should know that a standard die has 6 sides or 6 faces. How many states in the United States? I'm assuming that you know that there are 50 of them, if I have to ask any probability questions about that. Decks of cards, I find some of you may not be that experienced, so if you need to get a deck of cards and get yourself familiar with it, but you should know that there are 52 cards in a deck. There are 4 different suits. There are 2 different colors, just red and black. Half the deck is red, half black. And there are 13 cards in each suit, so ace through king of diamonds, clubs, hearts, and spades. And we can go over that in class if you don't know your cards. How many digits are there? That may sound silly, but there are actually 10 digits because we're talking about the digits 0 through 9. So 1 through 9 would be 9 digits, but 0 is a digit as well. So there are 10 digits. And then how many letters in the alphabet? There are 26 letters in the alphabet. Okay, I'm assuming that you know that. Okay, the fundamental counting principle. Fundamental counting principle basically says if you have 2 events and each one can occur in some number of ways, to calculate the total number of possible combinations, you just multiply them together. And that sounds very wordy, but let's just think of a simple example. You're trying to choose an outfit. You have some number of shirts to choose from. Let's say you have 5 shirts. And let's say there are 3 pairs of pants. So you have 3 different pairs of pants to choose from. And you have 2 different pairs of shoes to choose from. So if you're choosing one of each of those, if you simply multiply the number of each of them, it tells you how many different ways, different outfits you can choose. Choosing 1 shirt, 1 pair of pants, and 1 pair of shoes. So we multiply those together. 5 times 3 is 15, times 2 is 30. And that occurs, again, when you have some number of each thing and you're choosing one of each. Or if you can draw a tree diagram to illustrate the problem. And we'll focus more on that as we move along. So let's look at an example. How many codes are possible with the first character being a letter and the second being a digit? So the first thing I'm going to do is recognize that there's some number of each thing. So this is counting principle. The first thing is a letter. Second thing is a digit. So I like to just use a line to represent each thing. And then simply ask yourself the question, how many characters are there? So the first thing is a letter. So how many letters are there to choose from? Well, we just said there are 26 letters in the alphabet, so there are 26 choices for the letter. And then the second character is a digit. How many digits are possible? Any of the digits 0 through 9 are possible, so there are 10 possible digits. And the counting principle says that we simply multiply those 2 things together, and we get 260 possible codes with a letter followed by a digit. Okay. Let's look at a couple of situations where we might apply that and how we'll apply it. License plate questions, we love those in probability. So how many license plates can be made? Unique license plates, right? This might be important if you're a DMV worker and you're trying to figure out if you're going to have enough license plates for your state. You want to choose something that makes sense. So how many license plates are possible? If the license plate must consist of 2 letters followed by 3 numbers. So letter, letter, number, number, number. And so 2 letters, so I have the first digit or the first letter in this case could be any of the 26 letters of the alphabet. The second character in this license plate is a letter, so that's also 26 possibilities. And then followed by 3 numbers. Well, those numbers are always single digits in a license plate, so that's 10 possibilities. 10 possibilities, and 10 possibilities. And we're simply going to multiply those together. And 26 times 26 times 10 times 10 times 10. And we get 676,000 different possible license plates. 676,000 license plates. Now the second one's a little different. This is 2 letters followed by 3 numbers with repetition. Whoops, I meant to do that differently. So this should say without repetition. Repetition is not allowed is what I meant to say. Repetition is a big deal in probability. So in the first one, nothing said you couldn't have the same letter twice. You could have A and then A, or B and then B, or C and then C. You could have the same number twice. This problem, we want it to be not allowed, so no repetition. So there are situations where that might be the case as well. So in this example, you ask yourself, all right, how many letters could go in this first spot? Well, any of the 26. But now for the second one, you chose a letter for the first spot, so there are only whatever letter was chosen, there are only 25 remaining letters that could go in the second spot. Now for the digits, any of the 10 digits, 0 through 9, could go here, but again, without repetition, with no repetition, there's only 9 digits remaining for the next spot because you picked one. And now after you pick that one, you've picked 2 of the 10, so there's only 8 left. So you see that changes the probability, and in this case, now we get 26 times 25 times 10 times 9 times 8. And we see there are quite a bit fewer possibilities when we don't allow repetition of letters and numbers, 468,000 in this case. Okay, moving right along. So here's another example. How many ways can the digits 0 through 9 be arranged with no repetition? Hi, Mr. Daft. I'm making a video for pre-calc. You want to say hi to my pre-calc class?
That's cool.
I'll be done in a minute. How many ways can the digits 0 through 9 be arranged with no repetition? I think I just said that, but I said it again. Well, thank Mr. Daft for that. That's okay. All right, moving on. So I'm rearranging all 10 of those numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no repetition. So any of the 10 digits can be chosen for the first one, then 9 left for the second, and then 8, and then 7, and 6, and 5, and 4, and 3, and 2, and 1. And boy, is that kind of annoying to put into your calculator. Well, this calculation comes up so much in probability that we actually have a way to shortcut it. And you may have seen this before, but there may be some of you out here who haven't. And the way we write it is 10 factorial, like that. And we read that, 10! No, of course we don't say that. That's just one of my favorite math jokes. That's 10 factorial. And that literally just means that number times the number before it, times the number before it, and on and on and on, down to 1. This is a formal way of writing that. If it's n factorial, then it's n times n minus 1, which is 1 less, times n minus 2, which is another 1 less, and so on down to 1. And this is just shorthand. And any graphing calculator or scientific calculator will have a factorial button, so that instead of having to type that whole long thing in, you could simply type in 10 factorial. I want to show you where that is on your graphing calculator, because it's not on the main key screen. So I'm going to type in 10, and then you're going to go to math, because we're doing math. And you're going to go, you see over here, it says PRB for probability. So you're going to scroll over to probability, and you see number 4 is the exclamation point, and that is the factorial button. So 10 exclamation point, which we read again 10 factorial, press enter, and it does that calculation for me, 3,628,800. On your scientific calculator, that button is usually there. See, it's here, so I would type in 10 and then n factorial, and I get the same answer. And we're going to use that a lot, so get used to it, make sure you know where it is. Okay. Moving right along. Now, how many ways can the letters in each of these words be arranged? Well, very simply, math, 4, 3, 2, 1. There's 4 different letters. You could choose any of the 4 letters for the first one. Can't pick the same letter twice, because once you pick it, it's been picked. So there's 3 left for the next one, 2 left for the next one, 1 left for the next one. Anytime we're rearranging all the things we have, so all the letters, it's simply the number of things factorial. So that's 4 factorial, which happens to be 24. For this one, the letters winter, there are 6 letters all being rearranged, and that's simply 6 factorial. And again, you'd put that into your calculator, and I don't remember what that is. I think it's 720. Okay, now it's going to get trickier. Okay, now here we have letters repeating. So, for example, MOM, this M first and this M last, is the same as MOM if I put this one first and this one last. If they were different colors, you'd see that these were different. But since they're just letters and they're not colors, we don't want to count that twice. So even though there are 3 letters to choose from, 3 factorial, we have to eliminate the ones that are counted twice. Very simple to do that. Each number that repeats, so for example, there's an M that appears twice, so you're going to divide by 2 factorial, and that's going to cancel out the overlap. And so 3 factorial divided by 2 factorial, which you can put into your calculator. That you could probably do without a calculator. That's 3 factorial is 3 times 2 is 6, divided by 2 factorial, 2 times 1, which is 2, and that you really don't need a calculator for. The answer there is just 3 different possibilities. And you can see those possibilities, MOM, MMO, or OMM. There's really no other possibilities of rearranging those 3 letters, so this system works. Now it gets even trickier, noon. So here I've got 4 letters being rearranged, so 4 factorial, but I've got 2 different duplicates. So the N appears twice, so I have to divide out a 2 factorial. And the O appears twice, so I have to divide out another 2 factorial. Now when you put this into your calculator, you've got to put it in correctly. In other words, the denominator needs to be in parentheses. So you're going to do 4 math probability factorial divided by, and you got to put that denominator in parentheses or you'll get a wrong answer, 2 math probability factorial times 2 math probability factorial. Close up those parentheses. And there we go. There's 6 different possibilities. That's all for today. Thanks.